Welcome to this video. So in this video, we are going to solve question 3. Okay, so the question reads, the function h is defined by this, okay, for the values of x that are between k and 5. Okay, so the first question is sketch the graph of y is equals to h of x. So this expression here, the way they wrote it, x, and then they're saying x is mapping into 3x squared minus 4x plus 7, okay? This expression is the same as h of x is equals to 3x squared minus 4x plus 7. Okay, so the first question here, they're telling us to sketch this guy here. Okay, so how are we going to sketch this? We notice that this is a quadratic function. Okay, so to sketch a quadratic function, we need about three things. Okay, we need the turning point, we need the y-intercepts, and I can say that we need the x-intercepts. Okay, and then we also need the y-intercepts. Okay, so how can we find this? We are just going to simply complete the square on this quadratic equation. Okay, so we've done a lot of completing the square on question 2. So that video is available on our website if you'd like to watch that part. So when completing the square, we said we should always make sure that the coefficient of x squared is a positive 1. Okay, so what are we going to do to this equation? We're going to factorize a 3. So I'm going to say 3, and then in the brackets, okay, if I factorize a 3 from here, I'm going to remain with x squared. If I factorize a 3 from here, I'm going to remain with minus 4 over 3, okay, and then x. And then if I factorize a 3 from here, I'm just going to remain with 7 over 3, like this. Okay, so always make sure that if you multiply this 3 back with whatever is in the bracket, you get back your answer here. So if I do 3 multiplied by this, I get this. 3 multiplied by that, I get that. 3 multiplied by that, I get that. Okay, so here we're just making sure that the coefficient of x squared is a positive 1 like that. And then we can complete the square. Okay, so how do you complete the square? We said it's very easy. We first write it the way it is. Okay, x squared minus 4 over 3x. Okay, and then when we reach here, we create what we call as the special zero. So how do you create the special zero? You always get the coefficient of x. Okay, you divide it by 2 and then you square. So the coefficient of x in this case is 4 minus 4 over 3. So I'm going to divide this by 2. So dividing this thing by 2, okay, is the same as multiplying by a half. Okay, so this means I'm dividing this by 2. Multiplying by half or dividing by 2 is the same. So I get the coefficient there, I divide it by 2 and then I square it. Okay, so now I'm going to get this expression, add it to this expression and subtract it. No wonder we're saying it's a special zero. So I'm going to say plus, okay, minus 4 over 3 multiplied by 1 over 2 squared. So I've added it. Okay, so to not change anything in this equation, I'm going to subtract it like this. Okay, so you're adding it and then you are subtracting it again. So you have created a special zero and then you write whatever remained there, which is the 7 over 3. So that will be plus 7 over 3, like this. Okay, so we see that what we've formed here is what we call the special zero. So if you just form a special zero here, it means that the first 3 terms here, okay, are going to form what we call as the perfect square. So the perfect square, the way it is, okay, the way it is, it will make you write this in a summarized form. Okay, so what we have now there will be, okay, what we have now there will be h of x is equals to, I have 3 and then open brackets. So this part in green here, it's a perfect square. So a perfect square, you can summarize it in this form. Just get the x from the squared, okay? And then you get whatever is inside the brackets here. Okay, so whatever is inside the brackets there, what can we see? I can see a minus 4 over 3 multiplied by 1 over 2. So I can say 2 there, 1, 2 there, minus 2. So I'll just remain with minus 2 over what? Over 3. Okay, so this is what is inside the brackets there. So you get it with the sign that it has. So it is minus 2 over 3. And then I do what? I square. Okay, so it means I've summarized it. So if you were to expand this guy here, you'll get back whatever is in green here. Okay, so when we just want to summarize, okay, or to shorten a perfect square, we only consider these terms that have squared here. Okay, this one we can ignore it. Okay, so you ignore the 4/3, and then you just get the x here without the square, and whatever will be here without the square. Okay, you combine them, put them in brackets, and then you square them outside like I did there. Okay, so make sure you can check that if you expand this, you're going to get back whatever is in the green box here. Okay, and then I'll say minus what has remained here. Okay, inside here we have found that that is just -2, okay, over 3. So I'll write the -2/3 inside there, and then squared, and then plus 7/3, like that. Okay, so let's now combine the terms there. Okay, so we see that here we're going to have now 3, and then x -2/3 squared minus. So inside here, when I square, I'm going to have 4/3. Okay, so this negative inside here will disappear when I square. And then I still have this negative outside there, and then plus 7/4. So now we can add these two here. So that will be, okay, -4 over, um, -4/3, okay, -4/3, and then, okay, -4/3, and then plus 7/3. So, okay, so here, okay, I almost made a mistake. So let's look at this. So here we have a -2/3 in these brackets, right? So when I square the -2, I'll get 4. When I square the 3, I get 9. Okay, so I almost made a mistake there, and then plus 7/3. Okay, so now we can combine this. So that is -4/9, okay, and then plus 7/3. So the common denominator here is 9. So 9 into here to just be 1. 1 multiplied by the -4, I get the -4, plus 3 into here, it's 3. So 3 multiplied by 7, I get 21. So now 21 minus 4, that will give me a 17/9. Okay, so this part here, we have combined it. Okay, we have combined into a 17/9. So I'm just going to erase this part, and that 17/9 is a positive value, right? So this will become plus 17/9. Okay, and then from there we'll multiply throughout here by this 3, which is outside. So if I multiply this 3 with this, I get 3x -2/3 squared. Okay, and then 3 multiplied by 17/9, it means this 3 will go there 1 time, 3 there will go there 3 times. So I'll just have plus 17/3. So I have completed my square. Okay, I have completed my square on the quadratic equation. So it means my h of x in completed the square form is simply 3x -2/3 squared plus 7/3. Okay, so that is very good. Once we manage to complete the square, we can now find the turning point and the x-intercepts using the same this equation here. Okay, so the turning point, the x-coordinate of a turning point, you just get whatever is in the brackets here. Okay, you equate it to 0, and then you solve for what? For x. So this will give us x is equals to 2/3. So this is the x-coordinate of a turning point. And then the y-coordinate of a turning point, you get whatever is outside here. So that will be 17/3. So this is the y-coordinate of a turning point. So simply meaning that our turning point is 2/3, okay, comma, 17/3. Okay, so what is 2/3? If we put it in decimals, okay, it's approximately 0.6667, and then 17/3 in decimals, it's approximately 5.66 somewhere there. Okay, right. So that's what we have as our turning point, and then our y-intercept, we just get it from the original equation. So y-intercept is just a constant there, which is what? 7. So this is my y-intercept. And then we can try to find our x-intercepts. Okay, we can try to find our x-intercepts. So let's do that. Okay, let's do that. So we have h of x is equals to 3x minus 2 over 3 squared plus 7 over 3. So to find the x-intercepts, then we let our h of x be equals to what? To 0. Or we let our y be equals to 0. So this guy is 0. So it will be 0 is equals to 3x minus 2 over 3 squared plus 7 over 3. Okay, so we can take this guy to the other side. So it means I'll have what? I'll have minus 17 over 3 is equals to 3x minus 2 over 3 squared. Okay, so that is what I have. So from here, we can divide both sides by 3. Okay, so dividing by 3 is the same as multiplying by 1 over 3. So this side, I'm going to have minus 17 over 9. If I divide by 3 is equals to x minus 2 over 3 and then squared. So now we see that here I have a negative number and then here I have a number that I'm squaring. So if I'm squaring something, whether it's negative or positive, it's going to give me a positive number. Okay, it's going to give me a positive number. So meaning this expression here can never be true because this one indicates that this is a negative, this is a positive number, but here I have a negative number. So this simply means that there are no x-intercepts. Okay, no x-intercepts in this case based on this one here because the squared term can never be equals to a negative term. So there are no x-intercepts, okay? So we found the y-intercept. We've established that there are no x-intercepts and we also have the turning point. So meaning we can sketch our graph, okay? So let's sketch our graph somewhere here. Okay, so this will be my y, okay? And then my x can be there. Okay, so this is y, this is x. So I'll say, okay, let this here be 0. And then let this be 1 somewhere, 2. Okay, and then, okay, I can say let this be 5 somewhere there. And, okay, let this be 5 somewhere there. This is 6. And this is 7, 8, like that. Okay. So I'm just plotting the important numbers. So the turning point, we found that it was 2 over 3, 7 over 3. So 2 over 3 is approximately 0.66, okay? And then 17 over 3 is approximately 5.66, something like that. So the 0.666, it will just be a number after half, somewhere here, okay? And then the 5.66 to be somewhere here. So the turning point will be, if this is my 2 over 3, and then somewhere there I have my 17 over 3. So my turning point will be somewhere there. So that will be our turning point, okay? And then from here, we can plot the y-intercept, which is 7. So 7 is there. That is my y-intercept, okay? And then I do not have any x-intercept. So it means this curve will not touch the x-axis, okay? So if I can sketch it, it will be this curve that comes like this, and then it comes to 10 here. Okay, it will come like here, it will come like that, and then to 10 here, and then it will go like this. So this graph that I've drawn, okay, is the graph for h of x, okay, is equals to 3x squared minus 4x plus 7. Okay, so this is the graph here. So we have done the first part here where they've said sketch the graph of y is equals to this. Okay, so this one you can even say it's equals to y. Okay, so we've done part 1. Okay, and then they're saying from your graph or otherwise state the smallest value of k for which h has an inverse. So we know that for a function to have an inverse, then that function should be a one-to-one function, right? Okay, so if we use the horizontal line test to test if something is a one-to-one function, okay, we just draw a horizontal line anywhere on that graph like this. So if this line, the horizontal line that I've drawn, okay, it can even be there or there. If it touches this graph at 2 points like this, okay, at 2 points like that, 2 points like that, then it simply means that the curve that you've drawn or the function that you've drawn is not a one-to-one function, okay? It's not a one-to-one function. So it means for us to make this function to have an inverse, we need to limit the domain. because the way this quadratic equation is, okay, the domain there will be the set of all real numbers, because here it's going until negative infinity. Even this side is going until positive infinity. So if we don't limit the domain here will be all real numbers. Okay, so for us to make this function to have an inverse, we are going to limit the domain in this way. Okay, we're just going to cut it into two parts, okay, at the turning point. So the turning point is this guy here. So I'm going to cut here at the turning point like this. Okay, so this line that I've drawn in yellow is sometimes referred to as the line of symmetry because it cuts the quadratic graph into two equal parts. So this here, this line that I've drawn is x is equals to the x coordinate of a turning point, which is 2 over what? Over 3. So if I cut it like that, it means that this part starting from there going all the way to here, okay, can be considered as a one-to-one function if I just get that part. Or if I get this part here of the graph, it is also considered as a one-to-one function. Why? Because if I just get this part of the graph here, and then I draw a horizontal line like that, this horizontal line will just be touching it at one point like that. So meaning that it is what? It is one-to-one. Okay, so that's what we want to do there in order to find this value of k, because they said state the smallest value of k for which h has an inverse. So they said for this graph, the values of x should be from k all the way to 5. So 5 can be somewhere there, okay? So it will meet the graph somewhere where it's going here. If the graph is going, so 5 will be somewhere there, okay? And then the smallest value of k for which it has an inverse. So if it has an inverse, it means the domain has been limited, okay? So the interval, okay, of x being greater than a certain value, k, and then being less than or equal to 5, okay, it means the x is from this point all the way up to here. Okay, it means that x is running from this point all the way up to 5 here. Okay, we see that if we get this point, then the function will be one-to-one and it will have what? An inverse. So what is the smallest value of k? It's just this value at the turning point here, the x coordinate of a turning point. So the smallest value for k for which this function of an inverse will be 2 over what? 3. So if I get my k there, okay, and then all the way up to 5, this graph here that I'll consider here in the interval 2 over 3 to 5 will be a one-to-one function and it will have an inverse. Okay, so this is the smallest value of k. And then they're saying, okay, so this is the smallest value of k, right? So it means this x here, now look at this, x should be equal to, okay, or greater than 2 over 5, okay, but it should be less than what? 5, according to this. So now I've just put the value of k there. Okay, so once we do that now, it means for this part, we can find the inverse. Okay, even if they asked us to find the inverse of that part, okay, would still able to we would still be able to find the what? The inverse. Hey, Chizungu, guys. All right, so yeah, so that is it. Okay, so that's the smallest value of x and of k, I mean. And then we see that x should be equal to this value of k, or it should be greater, but it should be less than 5. Okay, so now having said that, we can be helped to solve this question here. So for this question, we are saying for this value of k, meaning this value of k, find an expression for h inverse. So we want to find the inverse now of this part here where we have limited the domain of this quadratic function. Okay, so let's find it now. So I will erase the graph. Okay, so let's find the inverse. So the inverse, okay, we can use this guy, the completed the square form, to find the inverse. So finding the inverse simply means we are making x the subject of the formula, right? So this will be where there's h of x, I put y is equals to 3x minus 2 over 3, and then squared plus 7 over what? 3. Okay, so from here, I'm going to see that our 3x minus 2 over 3 squared is equals to y. And then this 17 over 3 goes to the other side. So it's 17 over what? 3. Okay, and then from here, I can divide both sides by what? By 3. Or dividing by 3 is the same as multiplying both sides by 1 over 3. So I multiply this side by 1 over 3. Even this side, I multiply by what? 1 over 3. So what am I going to get? See, the 3 and the 3 will cancel, so I remain with x minus 2 over 3 squared minus, is equals to, and then here I can multiply the 1 over 3 with whatever I have here. Okay, so what am I going to get? Okay, what am I going to get there? If I multiply the 1 over 3 with whatever I have here. Okay, whatever I have there, what am I going to get? So there, I'm going to get, okay, I'm going to get what? I'm going to get y over 3. Okay, if I multiply the 1 over 3 with the y, minus 17 over 3, like that. Okay, no, not over 3 here. Okay, because this one to be 1 multiplied by 17, 17, and then this 3 multiplied by the 3, that will be 9. Okay, so that is what I have. And then, okay, so that is what I have there. And then I can actually combine this part. So it would be y over 3 minus 17 over 9. Okay, so 9 there. So this would be 3 into 9, so that would be 3y. Okay, with 3y. And then minus, okay, 17 like that. Okay, so that would be what I get there. Okay. Okay, so when we combine, we get this. So it means I have x minus 2 over 3 squared is equals to 3y minus 17 over what? 9. Okay, so let's continue with it. We are making x the subject of a formula. So the next thing here is to take the square root of both sides. So when I take the square root of this side, I have plus or minus the square root of this. So it means I have x minus 2 over 3 is equals to, okay, plus or minus the root of 3y minus 17 over what? 9. So this is what I have. Okay, so this will mean that I have x is equals to 2 over 3, okay, plus or minus the root of 3y minus 17 over what? 9. So now here I can distribute the root, okay, on this part. So root of, oh, okay, and I will just say this one here, this part here. It can be root of 3y minus 17 divided by the root of what? 9. But the root of 9 is 3. So it means down here I have 3. So I can put the 3 in front. So what I have is 2 over 3, okay, plus or minus 1 over 3, and then I have root of 3y minus what? 17. So this is what I have here. So this simply means that from the quadratic equation, you can't get just one inverse, okay? It will be dependent on where you have limited your what? Your domain. So this, the graph that we had drawn, okay, if you remember it, to something like this, and then we limited the domain from 2 over 3, okay, to somewhere 5, right? So we've got this part here. So this part, our x here will be what? Will be equal to 2 over 3, or it will be greater than this, okay? So from this expression here, I'll get two values of x. I'll get 1x is equals to 2 over 3 plus 1 over 3, the root of 3x minus 7. Or I can get x is equals to 2 over 3 minus 1 over 3 root of 3y minus what? 7. So this is what I get. So now, which one are we going to choose to be the inverse for the domain that will limit from starting this side going this side? Okay, we're going to choose the one that will give us an x value that will be equals to this or greater. Okay, so when I come to these two expressions, you can see here I have 2 over 3, 2 over 3. So here to this 2 over 3, I'm adding 1 over 3 and then root of 3y by 17. So it means this part here, okay, is going to be giving me x values that are greater than 2 over 3. And then here to the 2 over 3, I'm subtracting. So it means this x value here will be less than the what? The 2 over 3. So the one that is going to give me the x value that are within this range where the x is equal to 2 over 3 or it's greater than 2 over 3, it will be this equation here. So we are going to use this equation to find the what? The inverse, okay? But if we had limited the domain this side, okay, then our x there would be less than 2 over 3. So we'd use this guy here. But in this case, we're going to use this one to find the what? The inverse. So it means our inverse now, okay, will be, so I'm just using this guy here. So the x, I replace it now by the h inverse of x is equals to 2 over 3 plus 1 over 3, the root of. So where there's y now, I put back my x and then minus 17. So this here will be the inverse, okay, for the value k is equals to 2 over 3, which would mean that our domain for the x is between 2 over 3, okay, and 5. So this one here will be our what? Our inverse. Okay, so we are done with question 3a. We now look at question 3 part 2. Okay, so part 2, they're saying, part B, I mean, they're saying given that f of x is this and g of x is this. Okay, so this f of x has a domain, the set of all real numbers. This one has a domain x is greater than or is greater than minus 2. Okay, so the first question, they're saying state the range of f. Okay, so how can you state the range of this? The simplest way is just to sketch this graph. Okay, so on question 2, we're sketching a lot of exponential functions. We also sketched quadratic functions. Okay, so if you'd like to access that video, it's there on our website. You can just go in the links below here. You'll find the link to our website and the link to the registration video guide. So you can watch it and then you can know how to register, and then you'll find videos where we are sketching different types of what? Exponential functions. So for this one, we have f of x is equals to e to the power minus x minus 4. So we can sketch this easily. Okay, so we use transformation. So this is my y, and then this is my what? My x. So we said the generate function of exponential functions, okay, always has a horizontal asymptote at y is equals to 0, or in short, the x-axis. Okay, so I'm going first of all to sketch a to the power x, and then I sketch e to the power minus x, okay, and then I sketch e to the power minus x minus 4. Okay, so e to the power minus x will just be this graph that passes through at what? 1. So 1 will be our y-intercept. So how is 1 our y-intercept? We know that in the y-axis, x is always 0. So if you put where there's x there, you put 0. Okay, it will just be e to the power 0, and e to the power 0 is 1. So that's where this intercept is coming from. So now if I put a negative x in the power there, a negative x, then this graph here will be reflected about the y-axis. So it will come now like this. Okay, so this one in red is e to the power minus x. This one in blue is e to the power x. Okay, but my aim is to sketch this. So what this means is that, okay, remember I said the horizontal asymptote is at y is equals to 0. So if you see any number there, it means the horizontal asymptote is shifted to that number. Okay, so if it's positive, to be shifted up. Okay, if it's negative, to be shifted below. So this horizontal asymptote is at 0. Now here I can see 4. So it means the horizontal asymptote will be shifted to y is equals to minus 4. So this will now be our horizontal asymptote. Y is equals to this number here. Okay, so it will mean that even this point here, which was the y-axis, has to shift down because this horizontal asymptote has shifted from 0 to minus 4. Even this point has to shift 4 units below. So 1 plus minus 4, that will give me what? Okay, 1 minus 4, that will give me a minus 3. So it means this point here has shifted to this part here. Okay, so it means our curve now will be not touching the y-axis. I mean, not touching the y is equals to minus 4 like that, and then it passes there and then it goes like that. So this one is e to the power minus x minus what? 4. So to find this point on the x, okay, you just say, let my y be equals to, because this will be the x-axis, right? So you set your f of x to be equals to 0. And then you solve for x, you see that this point is just minus and in 4 like that. Okay, so from this graph, we can easily, okay, we can easily get the domain and the range. So the domain, okay, you see that this graph will be coming from minus infinity when you are considering the x direction, okay, this part or this part. So it's coming from minus infinity, and as it rises here, it's also going this direction. So no wonder the domain there, they said all real values. And then the range will be, okay, the lowest y point that it is approaching. So this green graph here, it is approaching y is equals to minus 4. And then as it is going like this, it is rising to positive infinity. Okay, but it never reaches the y is equals to minus 4. So it means the range will be from minus 4 all the way to what? Positive infinity. Okay, so that will be the range and the domain for this function here. So maybe I can write it on top here because I'll refer to it when I'm finding um, the domain of the inverse. So if this is the domain and the range of the original function, then when I find the inverse function, okay, its domain will be this range, and then its range will be this domain. Okay, that's how it works. So the range of the original function is the domain of the inverse function. Okay, the domain of the original function is the range of the inverse function. So this function in green, it has an inverse, okay, because when I use the horizontal line test to test, okay, if I can draw a horizontal line anywhere, to just be touching this thing at one point like that. So meaning it's a one-to-one function. No wonder we are able to find its inverse here. So now let's find its inverse. Okay, let's find its inverse. So the range we found that it's from minus 4, not included the minus 4, all the way to what? Positive infinity. So to find the f inverse, okay, I'll go here. So I'll replace the f of x with y is equals to e to the power minus 4, minus x, I mean minus 4. Okay, I want to make x the subject. So I have e to the power minus x is equals to y plus 4. Okay, and then from here, I'll introduce ln on both sides like this. So this will give me what? Okay, so this minus x will drop in front. So that will be minus x ln e, but we know that ln e is always equals to 1. So this will be equals to ln of 4 plus a y there. Okay, and then I divide both sides by a minus 1, minus 1. It means my x will just be equals to minus ln x plus what? 4. Okay, so I write it in terms of the inverse. This will be the inverse of f of x is equals to minus ln. I put back my x there plus 4. So this is the inverse. So in case they ask you for the domain and the range of this inverse, you just say the domain, okay, will be the range of the original function. So this will be the domain here. And then the range to be the domain of the original function, which is all real numbers like that. Okay. So that will be the inverse, and we are done with part 2. So let's look at the last part on this question. Okay, so the last part, they're saying express f of g of x as a polynomial in x. Okay, so we see that this is the same as f of g of x. So this simply means, okay, in the function f, wherever there's x, I have to put the function of what? G. So now g is equals to ln, and then I have 1 over x plus 4. Okay, so this is the same as ln. Okay, so remember, if I had, if I have a to the power minus 1, okay, if I have a negative power, it's the same as 1 over a. So this is what we see there. This 1 over x plus 2 is the same as x plus 2 to the power minus 1. Okay, and then by the laws of indices, it means I can drop this power in front, the minus 1. So this would be minus ln x plus 2. So my g of x, okay, which is this guy, I can also write it as this guy. Okay, and remember, it has a domain of this. Okay, so when finding the composite function, we always consider the domain of the input function, because this g, we are getting g and putting it into the function of f. So we have to consider its domain. So don't forget about the domain. But this g can also be written as this, right? Okay. So now what we're going to do is that in the function f, okay, remember the function f is this one. Okay, so wherever there's x, I'm now putting the function g, but the function g is this one. So it will be e minus, and then where there's x there, I put the function g. So the function g is minus ln x plus 2, okay, and then I have that minus 4 somewhere here. So we see that this will be e, and then negative multiplied by negative, that will be ln x plus 2, and then minus 4. So now here, we have to remember the properties of exponentials. We said if I have a to the power log base ab, this is the same as what? B. So this is the situation that we see here because ln is the same as log to base e. So it means what I have here is e, okay? The ln, I replace it with log base e and then x plus 2. So this guy will cancel, just like this guy cancels out because it's this guy, e, raised to log with the same base as this. Okay, so I just have x plus what? Plus 2 there. So it means here, this guy collapses. So I just have x plus 2 minus 4, which is equals to x minus what? 2. So this one here will be our f of g. So this f of g, it will only work for a specified domain of the input function. So the input function has a domain x is greater than minus 2. So this here will be our polynomial, okay? But for specifically this restricted what? Domain. So we are done with that question, okay? Okay, so thank you so much for watching that video, okay? If you'd like to access more videos, um, on different mathematical topics, okay, so you are free to register with us. So on our website, okay, we would like to inform you that we have full solutions to all the tutorial sheets that you've had, okay. So as you are preparing for your tests, as you are preparing for your mid-semester exam, even the exam, okay, always make sure that you know how to solve all the questions in the tutorial sheets. So tutorial sheet 1 is this one. We've solved all these questions here. We've explained each one of them, and the videos are available on our website. Tutorial sheet 2, we've also solved all these questions on the exponentials, okay? And the videos are available on our website. So you can learn at your own time, at your own pace. We have videos to all these tutorial sheet. Tutorial sheet 3, which is this one, okay? So those questions that we are solving, I got it from tutorial sheet 3. But again, we've solved all these questions here in tutorial sheet 3, and you can access the video on our website, okay? Tutorial sheet 4, which is on sequences and series. Again, we've solved all these questions here. So make sure that you gain access so that you can watch them and then prepare for your mid-semester exam as well as your test. Okay. So sometimes they just get the same questions from the tutorial sheet. And then even tutorial sheet 5, which is on differentiation and integration, we've also solved all these questions here and they're readily available on our website. Okay. You can also check quiz 2, quiz 1 that you wrote. We've solved this quiz, okay? We've solved all the questions and they're available on our website. Okay, so when you go on our website, okay, you'll find something like this. Okay, so once you register for your course, it will show enrolled there for the courses that you're enrolled. So if you want to access those tutorial sheets that I was showing you, you can just say open course, okay? And then you go to general math. Okay, so here in lessons and tutorials, we have lessons on each and every topic that you can learn in math. Okay, so you can go there to learn the topic. And then here we have handwritten summarized notes, well summarized notes, so you can use them for your studies. And then if you want those tutorial sheets, you just come in this folder, tutorial sheets and assignments. Okay, so depending on the university where you're from, those tutorial sheets are from Unilus, so you go from to the folder for Unilus. Okay, and then that was first semester, so you click first semester here. Okay, and then you go to the video solutions here. If you want, you can check out the written solutions here. So if you go to the video solutions here, you're going to see that we have 2 intakes so far, the January 2025 intakes, then the July 2025 intake, which is this now. Okay, so you can just open this 2025 July intake. folder, you're going to find the videos. You can see here tutorial sheet 1, tutorial sheet 2, tutorial sheet 3, tutorial sheet 4, tutorial sheet 5. So we have 4 videos for all of these questions here. Okay, so you can open maybe tutorial sheet 2. Okay, we try to check if there are videos there. You see that there are videos there from question 1, 2, 3, 4, 5. So we just had 5 questions in that tutorial sheet. We solved all of them. Okay, and we also solved some assignments. Okay, some people sent me this assignment, we solved it. Okay, so you can access it there. So make sure that you watch all these videos, then you'll be good to go um for your exams. Okay, so if you want, you can also check out the past paper sections. So past paper sections, as we'll be writing your test 1. Okay, we have the test 1s for the past intake. Okay, so you can actually access them and learn. Okay, you can actually access them and learn. Okay, so here you see that we have past papers, so you can open the past quiz test and exam papers. Okay, you go again to Unilus since the Torch that was solving was from Unilus. Okay, first semester. Okay, uh, and then video solutions here. Okay, so I'm going to find the video solutions for the tests last year. Okay, so this was test 1, this was test 2. Uh, you can watch this and then you can learn at your own time. Okay, so thank you so much for watching this video. Remember, if you need any help, you can contact me. So in the description here, you're going to find the link to our website and the link to the registration video guide. So you can watch it and know how to register on our website, and then register. You'll be learning these things at your own pace, at your own time. So the good part again is that we have a mobile app. So on the mobile app, you can actually download the videos when you're in school, and then you can watch them offline anywhere. Okay, so when you go to school where there's Wi-Fi, download the videos. When you go back to your boarding house or your room, okay, you can watch the videos offline anytime on our mobile app. Okay, so thank you so much. It has been Tutor Poul Solutions. Until next time.